Okay, we continue. This is the most painful part of your homework is because there's a more quadratic equation. What is the pH? Asking for pH, right? Of 0.050 diethylamine, which is C4H10NH. All the amines that have the nitrogen are bases and are weak bases. Just to, I'm going to explain something real quick, but with a Kb of 5.9 times 10 to the negative 4. Okay. Um, what makes when you got an acid and a base, okay, let's say you got ammonia, you got HCl plus ammonia, which is NH. I don't know if you remember the Lewis structure, but it's this one with two lone pairs. All the amines, all the organic compounds with the nitrogen that contain nitrogen have this. And this is two pairs of electron, lone pairs, it's called. And this is the one that attracts the hydrogen. And that's why the HCl, for example, forms the Na. Let me do something here. Hold on. Okay. And this is gonna be, I'm gonna do it like that. H, you see? N, H, H, H. And this is the ammonium plus Cl negative. In other words, it's NH4 plus. Okay, that's why. So let's go ahead and keep on going with the problem. I thought it was important to explain to you why they are, and all are weak bases. So it's asking for the pH, okay, of 0.050 m, and with a Kb of 5.9 by 10 to the negative 4. Now, if you have this, right, we know already that we have to do the whole quadratic equation. Why? Look at this Kb and look at the value of the initial concentration. So let's do the ionization of our base, weak base, NH plus H2O, and remember, water is acting like an acid now, okay? Because in water is the one that gives the hydrogen to C4H10. I'm writing NH2 plus, and then you got plus OH negative. Okay, you're producing OH. So here would be initial initial 0 point I forget about it. ICE. So this is 0.050. This is 0. This is 0. 0.05. Well, you see, I'm doing it all directly. Again, doing the same thing. Sometimes it's a pain. Okay, this is gonna be minus x, x, and x, and this is gonna be 0.050. Directly, I'm doing it the equilibrium concentration. I'm jumping that all the time. I hope you don't do it. 5, so it's KB. Okay, let me write it because the KB is different, but it's the same thing as the acid. C4H10 NH2 plus multiply by the OH divided by the base. Diethylamine. So divided by the C4H10 NH2 NH. I'm gonna do this. Okay. So KB would be 5.9 by 10 to the negative 4. 5.9 times 10 to the negative 4 equals x to the square divided by, and this was 0.05, right? And again, I forgot that. I just saw that I made another mistake. Sorry. You probably noticed it already. I hope so. So it's 0.050x minus x. It's too early in the morning. 6 o'clock, 5:30. So we cannot drop it. I wouldn't drop it. If you want to try to drop it and see what you got, try. But I can tell you right away that it's not going to work. Okay, what I was doing is that what I did is took the value I got from x with the whole equation and just did the 5% and it gives me like 10%, so there was no way we could drop it. So 5.9 by 10 to the negative 4 multiply, I'm taking this to the top, 0.050 minus x equals x to the square. So this is going to be 5.9 10 to the negative 4 multiplied by 0.050 minus 5.9, doing distributive property, remember, 10 to the negative 4x equals x to the square. So this, taking it all to one side and doing and multiplying this, it gives me x to the square plus 5.9 times 10 to the negative 4x minus this multiplied by this gives me 2.95 times 10 to the negative 5 equals 0. So let's do the equation, and it's going to be minus b, which is 5.910 to the negative 4. Plus minus, you know already you can't use the negative, but let's put it the correct way and at the end. The square, 5.9 by 10 b to the square, right? Minus 4ac. And 4a is 1. And this would be minus c is 2.95 by 10 to the negative 5. And this all divide 2, and c is 1, 2. C, a is this value, 2 divided by 2 multiplied by a, and a is 1. So we got x equals minus 5.9 by 10 to the negative 4 plus minus this to the square is 3.48 times 10 to the negative 7. Again, minus and minus gives you, this is a minus. Minus and minus gives you 4 plus, and this is going to be, this multiply 1.18 times 10 to the negative 4. Just a reminder, if you see me those numbers where you're going to wonder where is she getting, I remind you that I already did the calculation, so the video wouldn't be stopping or taking a long time while I do the calculations. So they're already done. I'm double check and everything. So x would be equal to minus 5.9 10 to the negative 4. This divided by 2. And this would be this plus the other square root give us, just do the operation if you want to. You add this and then you do the square root. And by the way, this is negative 4. And it's going to be 0.010879. Again, for a concentration, I can't take the negative, so it's going to be minus this plus I have to do something. Hold on. Okay, I didn't have space enough, so I was getting the next problem down. So it's going to be 0. This is going to be the positive. Okay, you can't use the negative. So you're going to use minus 5.9 by 10 to the negative 4 plus, if you use negative and negative, it gives you negative. So 10879 divided by 2. This equals 0.0102 89 divided by 2. And this is going to be, x is going to be 5.14 10 to the negative 3. Now, x is the same as the concentration of hydroxide. I'm going to get it up so you take a look, right? is the same as the concentration of hydroxide, right? So the concentration, I don't want you to get lost because they're asking for the pH. So the concentration of hydroxide is equal to 5.14 by 10 to the negative 3 m. So now, knowing that, we can find out because it's asking for the H3O, the pH, so we have to find out the concentration of hydronium in solution, even if there's very little of it, because it's a basic solution, but we still have some. So that's why we can determine the pH of a basic solution. And it's 1.0 times 10 to the negative 14 divided by 5.14 times 10 to the negative 3 equals, this is the Kw, divided by the concentration of OH, and it gives me 1.9 times 10 to the negative 12. So the pH would be minus the log of 1.9 times 10 to the negative 12. And the pH would be equal to 11.71. Okay, and that's it for problem 22. Long ones with the quadratic equation. Okay, 22 and 23 are basically the same. And 24 also. So let's do 25. Chosen because we don't have the KB. And they didn't give it to you, so I have to give it to you. You can find it on your book on the internet. But the problem, the Connect didn't give you the KB in this one. And it's 25. And see, what is the pH of aniline? Aniline. So the 25 is asking of 0.42 molar of, and I write you the formula, C6H5 NH2. As you haven't seen organic chemistry, I had to write you those formulas. Okay, so C5 NH2. Okay, and the Kv for this base is gonna be 4.3 times 10 to the negative 10. So here we got C6. Let's write the ionization so we can solve it. NH2. Basically, you wouldn't need to, but yes, on the test I want to see it. So it's gonna be C6H5 NH3 plus OH negative. So I see again If they don't give you the KB, what are you going to do? You only have the concentration of the base and that's it. You can't do anything then. So this is going to be 0.52 molar. This would be 0. Let me see if I write it right, do it without a mistake. And this would be minus x plus x plus x. And this would be 0.42 minus x, x and x. So let's write the expression, and directly we can do it. The KB that I gave you for, if you want to find it in the book on internet, you see is the same one. Negative 10 equals, right, x to the square, right, divided by 0.42 minus x. First of all, this is not very small. It is, but, and this, wow. So there's no doubt that you can drop that x. So this is going to be 4.3 times 10 to the negative 10 multiplied by 0.42 equals x to the square. So this is going to be x is going to be square root of this 1.806. We've done it so many times by 10 to the negative 10, and x is equal to 1.34 times 10 to the negative 5. Now there's two ways, okay? And it's asking for the pH, right? So you have to find a concentration of hydronium is equal to 1.010 to the negative 14 divided by the x, which is the concentration. This is the concentration of OH, of hydroxide, divided by 1.34 times 10 to the negative 5. And I'm going to do the math because this, okay, here it's 7.4610 to the negative 2. That was the concentration of hydronium. So I didn't round it to 7.5. I did round it, and then it got me 9.12 here, but it's 9.13 according to Connect. So you got pH equals the minus log, so I left these two decimals to 3 sig figs. And basically 3 sig figs gives you the two decimals in the on the pH. That's where they got it. 7.46 by 10 to the negative 10. That is going to be, the minus log of that is going to be the pH. Okay. Go to the next one. And it's 26. Those are short. We can do it 5. I don't know, at least the A. Okay, what is the pKb of NO2 negative? And where did you get it from? Okay, you get it from NO2 negative, right? It's the conjugate base nitrous acid. of the nitrous acid. And it's going to be it plus uh, H2O, change colors, yes, H3O plus NO2 negative. Now this is the conjugate base, and the problem is asking for pKb. So the first thing we have to do is find the the Kb. I'm sorry. The first thing, yeah, we have to do is finding the Kb. Okay, that's the first step. From where? Remember, Kb, I show you this. Kb, kind of the same as the pH and PO, the hydronium and it's, we were here on the PowerPoints. Here, this one. Um, yeah, this one. Ka by Kb equals Kw. I'm going to go through that again, but you know that now. And that's the way Kb multiplied by Ka equals Kw. And it comes from this. Let me show you real quick, and I'm going to teach it again. And let me show you. This is the acid, right? And this would be the conjugate base of the acid. Okay, the ionization of both. And you add them, and it gives you the auto ionization of water, which is Kw. So the Ka, okay, oh, I can write. The Ka is equal here. Here's the Ka, here's the Kb. And remember, when we add two equations, the k's you multiply it. So the k for the overall would be Ka multiplied by Kb. That's where we got it from. And, I like to, this is the acid, okay? This H2O, hold on, the ionization of the acid, right? Which is going to be, what is what I'm doing? Because they're asking for the pKb and they're giving you the Ka. So this would be a Ka, right? This NO2, the conjugate base, plus water, now it's going to go back to the acid, plus water. And I'm going to start erasing that. This is water, okay? This is water. And gives you, I'm going to erase both of them because, okay. NO2 plus water gives you back the acid plus OH plus OH negative. And this is the Kb, okay? And if you cancel out this and this, you add them, both of them, right? NO2 and NO2. This is going to give you on the left side 2H2O and H3O plus OH negative. And if you look at here, it's, remember the K, when you add two equations, it's going to be multiplied. And what is that? This is KW. That's where they got it from. Okay, so now you got, right, that KB multiplied by KA gives you KW. Now in this problem, they're asking for PKB. But to find PKB, you need, look, you need KB. And to find KB, they're giving you KA. So you can do, right? First, with KA, find KB. And with KB, you got it already, you can find PKB. And that's what the problem is asking for. So KB equals KW divided by KA. And the value of KA that the problem gave us is 7.1 by 10 to the negative 4 equals 7.1 times, okay, first it goes the, on top goes the KW. What a pain this. So it's going to be here, KW 1.0 by 10 to the negative 14 divided by KA given, which is 7.1 by 10 to the negative 4. Yeah. And this is going to be, you're going to get a KB here of 1.408 times 10 to the negative 11. So PKB would be minus log of this value of 1.408 times 10 to the minus 11. So PKB would be equal to 10.85. Then the part B would be kind of the same thing, but the opposite. Okay, this would be, they give you the KB, right? So you have to find the KA because they're asking for PKA. So KA first would be the KW, same thing, divided by 8.5, which is the KB, by 10 to the negative 5. So KA would be 1.176 times 10 to the negative 8. And this is going to be, that's a Ka. pKa would be equal to the minus log of this, which 1.7176. And then it takes so long. Okay. 1.176 times 10 to the negative 8. So pKa sorry guys, equals 7.93. Okay, I hope it's not too long. Let me see. No, it's okay.